Yeah, that's
Share. Good. All righty. Thank you, sir. Thanks, everyone, helping me out with this screen. So again, my name is Mohsin Shaik. We're here for introduction to containers, especially on KSL platforms. So I think let's keep doing this. Yeah, it's easier. So essentially, we are 4 people here who have worked on the slide deck, and we usually do in and out work on containers, depending on the uptake of the containers and the requests. So Dr. Halimi and Dr. Didier are from Chaos Visualization Lab, and myself and Dr. Kadir are from KSL. Now, today, what we want to cover is an overview of container technology in general, and then we'll move to Docker Engine, just hands-on experience with it for those who don't know it. And then we'll talk about Docker files. I know there are a few people who will feel bored in these sessions because they know it already, but bear with us. We will write the Docker files so that they are portable between your workstation and a shared machine like Shaheen and Ibex. There are subtle differences. They are not documented universally. So we feel the pain and we try to mitigate the pain, and then we try to deliver it as a practice. It may not be best practice universally, but it is best for the shared system. It is safer for the shared. And the end outcome is pretty much the same of the container. So it doesn't get affected. Then we talk about something called singularity. So surprise, surprise, we talk about Docker, but we don't run Docker. And there is a reason why we talk about Docker. So I'll explain it a little bit in the future. But we use what's called singularity, which understands Docker written images. Okay, so that's the link between the two. And then we talk about how to run these images and containerize them on the KSL platforms. We'll be working on Ibex. Can please anyone raise their hand who don't have access to Ibex? Okay. So can anyone please confirm they have never used Ibex? Fantastic. That's the quietness I wanted, because then you have the login and the SLAM association, so you can run jobs. There are no specific reservations for the system today. It's a very, very busy system. So please try your luck. Whenever the job runs, it runs. If it doesn't run, look at your neighbor's screen. HPC containers with singularity on Shaheen. Shaheen is down today, but we have Kadir, who has run everything, and he's going to talk about the whole tested workflow. The workflow is published in GitHub, so you can actually do this at home afterwards if you wanted to. And Ibex. So Ibex has examples. I'll be showing a few examples, and I think you guys are going to do the same. Okay, the material is there. You already know it. For those who don't, please download the slides from the HPC page. So you go to hpc.chaos.edu.sa and try to find this, or maybe take a picture of this. Right? Okay, without further ado, let's talk about the overview. So, what are containers? From a purely software engineering point of view, and not being too computer sciencey here, what I see it is it's a method of isolating a single portable compressed file, right? So that's how I look at it. It brings everything, batteries included, for your application. That's the important thing. At the moment, it's not a general purpose computer that you're recreating up in the cloud, okay? You're trying to focus on your application, right? Maybe broken down application in certain scenarios, and then try to support it so that in runtime, it does not feel anything is missing, right? Such that it has the operating system it wants. It needs a file system that it can talk to, It has the system tools and libraries. For example, the package manager, right? The apt-gets and all those things, and the code that you have written, and the runtime it requires to run that code, the libraries for that specific application. That's it. That's the minimalization of the whole scope. The next part is basically, okay, that's fine. But what is the basic difference between a bare metal, that's your workstation, for example, a virtual machine, a VM, and a container? So bare metal installs optimized stuff. So you work on your machine, you try to optimize for the machine so that your application runs as fast as possible on your machine, or as conveniently as possible, right? What if your supervisor buys you a new laptop? You have to do all of that on that laptop again. It takes time, right? So this is clunky movement, but at the end of the day, when it is there, it is going to run the fastest possible. So that's the good and the bad on a very superficial level for the bare metal. A virtual machine, for all intensive purposes, is just like a container, but a virtual machine is going to run in one of the two modes. It may actually be running on something called a hypervisor, which is going to virtualize the hardware that you are running on, right? And it is going to encapsulate every single thing, such that a virtual machine is a single computer. The disk, the networking, the operating system, the kernel of the operating system, your application, every single thing, detached from the rest of the world, unless you wanted to connect to another virtual machine. You can have multiple virtual machines running on the same machine without it knowing about its neighbor, right? This comes at a cost. I just mentioned there is something called a hypervisor, right? So that hypervisor is the way the virtual machine talks to the underlying hardware, which is actually going to do the thing. This is an overhead, right? There is a huge convenience that you are doing your own thing on the same machine, whereas everyone else can actually reside on that same machine and do their own thing. But the cost is the performance of it, right? You can package it and take it somewhere like cloud instance, for example, and unroll it. That's called an image, right? An ISO image most of the time. But it is going to be a big one, right? The images are usually big when you actually bring the whole kitchen sink with it. Now, remember, what was your intent? Your intent was to run the application, right? So this is not an application-oriented scope of the system, right? It is a system that is running the application, right? It is not the application that dictated the engineering of the system itself. So people started to think about it, and Linux containers are not a new thing. They have been there for quite a long time. So what they said, okay, fine, what do we actually need for the application? And that's where the talk started. It encapsulates the minimal OS required, right, in the user space. That's the most important thing. It does not encapsulate the kernel of the system, right? So it is going to use the host OS's kernel, right? So if it is a Linux kernel 3.something.something, your container is going to see the same and use the same. It has an upside. I'll talk about in a minute. And then your software and your libraries, right? These are the things that you will encapsulate. Once you're using the container and you're using the kernel that has host, basically you can share the kernel between multiple containers all on the same machine. So that's one thing. The container becomes lightweight all of a sudden, right? Because it doesn't encapsulate the networking. It doesn't encapsulate the unnecessary parts of utilities. It doesn't encapsulate the services that are running on the system for keeping the system up, right? So these are a few things that you're not virtualizing. What the kernel will do is it will give you a better performance close to the hardware, because remember, the OS is the kernel itself here, and the container is going to request the kernel to do all the things. So you get a better performance as well. lightweight and better performance compared to VM. Now, do we give away a lot of portability? Actually, we regain a little bit of portability if you think about it. If a VM is using, so VM can run on bare metals as well. You don't have to have a hypervisor. But when you have a bare metal running a VM, again, you're closer to this hardware. So portability is also a question. So when you go to another hardware, you have to have an emulation of that hardware, a similar hardware to get a similar experience. Otherwise, there'll be some things clunky. An example would be running your VBox on Linux versus Mac versus Windows. When I say Windows, everyone would say, oh God, I just moved from Windows just because of that, right? Because it's damn hard. So all things considered, what we're saying is containers are there to scale better due to low overhead. Containers are there to share the host OS kernel so that it can perform better. They are faster to deploy and faster to destroy because they are lightweight, right? So this is a very important thing if you're doing things repeatedly, right? So, and then the other thing is, how many people have deployed their own VMs on a remote machine? You need an admin. Even if you have done it yourself, you need an admin. You need some sort of understanding of at least how to expose the IP address to actually SSH into it, which ports, which you need to know computer science for that. You shouldn't need to know computer science for your applications running, right? Because you know your application, right? So this is another, the thing that people came up with. Okay, fine. Do we really need to do computer science to actually move from one place to the other place? Right? I know my application, I know my WARF, I know my database, so on and so forth. Then can run within VMs too. So containers can actually run within VMs as well. So like compute instances in the cloud. Okay. So why containers? So we have been talking about containers and then we are talking about the motivation itself. So let me encapsulate it. To make things portable, and the branch of portability is the instruction set the hardware is running, whether it is x86 64-bit or ARM 64-bit. These will be two different containers. They cannot understand all the things in the world, but you will have a same application installed in two types of containers if your targets are both. If not, then don't care. Software remains frozen from laptop to HPC to cloud. That's the, the ideal scenario. And there are a few gaps here, there, and there, but we try to fill them. Reproducibility of research. That's a very, very important thing. So you publish something, you give it away, and then the other guy has to do the software bit first in order to run the application the way you ran it, right? This is a clunky thing because the wheels will fall off, simply put. People won't do it. This increases collaboration, right? It's guaranteed to run. It's guaranteed to run. That's the idea. The image contained everything that is required, so it will run, hopefully. Sharing and collaborating, as I mentioned before. Ease of use. The use, so basically you have been working on your workstations, right? All of a sudden you come to Shaheen and Abex, and then we ask you to do things absolutely differently. Right. And then you sometimes feel, okay, fine, I can't even install something with AppCat. How do I install my stuff now on Shaheen and Ibex? And then you talk to the computational scientists, they will work with you, takes 5, 7, 8 days for one library to happen. And maybe they come back after 5 days, we can't do it because it's orthogonal to what we are doing. So it gives you an environment that we know, that Ubuntu plus Conda plus Pip plus blah, blah, and even Java, right? Right. So okay. Maintain version of the software stack as well. So this is something that is very, very important for people who are doing really, really, resilient work where they have users and uptime is absolutely important. So you are here, the software lifecycle is moving, right? They are having new versions all day long, right? So whenever you install, pip install, everyone will end up with a newer version and the behavior of the application will start changing. This is a way to freeze that environment as well. So they don't have to do it. It's one version installed there, you unit tested it, it's working, publish, it's gone. They do the container from the image, and then that's the same experience without the possibility of it breaking, right? It's composable. So we spoke a little bit about the APIs, for example, and we have someone who is cataloging stuff. Sometimes you want to see the system, your application, and you want to isolate tasks, the relevance of the work of the application's parts, right? They might not be a monolith then. They may not be residing in the same environment all the time. Your part of the application requires Apache, for example. The other part requires the client-based compute. Why do you need to bring them in one place? So that if Apache goes down, everything goes down, or vice versa. That's not a robust system. So what people look at it as, can we break it down into two pieces, such that these were two connected machines, such that if I actually have this as my database, and if I have this as my client or front end, these two are two different systems. This is called distributed system, right? In distributed system, what you can do you can containerize the two things. It becomes lightweight. And then you can orchestrate, and that orchestration is the composability part. The next one is kind of related to it. When you need something like that, you need to go into the container world so that you can use the workflows that can actually orchestrate your containerization. So Kubernetes, Argo, MLflow, Nextflow, and there's so many of them now. They actually understand containers. They orchestrate the way that you want it to, and so on and so forth. So this is something that is kind of a prerequisite for the modern way of doing multitask architecture or distributed system design. Okay. So the general workflow on a very, very high level, as I would explain to my 5-year-old, is you have your Docker file, you build your Docker file, right? Compressed file, that compressed file I was talking about, all things included. You may test your Docker file and create a container out of it, the runtime, and then test it basically. And then when you're happy, you can push the Docker file to something central where you can archive it, where you can version it. That's called a registry, right? And if you want to basically do some changes, you go to square one, change the Docker file, and then you do the whole thing. Some people mentioned here the CI/CD, the continuous integration and continuous deployment. This actually is a workflow, which when gets automated, ballpark is called CI/CD at the end. It's a lot of complications, complexities, but it is brilliant when it is working. Okay, from a container platform perspective, well, we know about the bare metal, but then we know about the VMs as well. There is in the cloud, we have seen this Azure instances, the AWS instances, and all those things. But they are running an extra software that can make things happen for you. There are container platforms that can give you the utilities that you require to actually do those steps that we talked about, right? So cumulatively, the collection of those utilities is called a container platform, right? There are so many of them, but these days there's something called Open Container Initiative, and it is basically a standard which defines how things are spec'd. If a container platform is adhering to that, that's called an OCI compliant container platform. We like that platform, okay? Because what it does is, for example, an image, it describes how an image should write. So if a container platform is writing the image that way, that would mean that this image, when published, can be plugged in and be run by another container platform. And that's a good interpolation of the things. So you can at least move from one to the other system where the other system may actually be hosting another container platform, but your container image remains the same. You never change that. At least that's the idea. Okay, so here I'll break off, and then Dr. Halimi is going to come and talk about Docker engine, and then we talk about writing the Docker files and how to deal with the Docker registry to complete this code. So over to you.
Yes. For a bunch of days, I back to Praveen, and if I want to run my campaign with Postgres, where should I put this, in my area, or should I put it in Scratch? Is that a best practice? Or...
So there are, from a disk point of view, there are isolated areas, absolutely.
Okay.
We have shared file systems mostly.
Okay.
Postgres doesn't like that most of the time, but we do have NetApp running NFS. So from a prototyping point of view, if you don't have a huge amount of data, then your home directory is fine with Postgres.
What you call much database? What you call big database?
So you have 200 gigabytes to play with in the NFS.
Okay. So hello everyone, I hope you are doing well. I'm Dr. Abdelghafour Halimi, and I just recently joined the cross-organization call-out as a data scientist. And today we're going to try to talk a little bit about Docker and to see why it's a powerful tool and how it can be useful to know how to use it. So first of all, what is Docker? Docker is just an open source platform that allows us to create and build and run any application as a lightweight portable sufficient container that will run virtually anywhere. So one great thing about Docker is that it can be used on many different platforms, including Linux, macOS, Windows, WSL, which I'm gonna, by the way, use for the demo. So this means that you can develop, test your own application on your own local machine, and then deploy it into production environment, which can be used in other operating systems. So Docker makes it easy to create a consistent environment, which is gonna work across different operating systems. And at the end, it helps us also to avoid the very known works on my machine problem. So this is the idea, but this is not specific only to Docker. It's a concept for container, and it's gonna be the same thing with singularity that we're gonna see later. So this is the idea. So how do we get started with Docker? First thing that you need is to install Docker into your local machine. So I hope that this is the case for you all. If it's not, I put some links. And here, I don't know why it's, yeah, okay. We're gonna try to see the most, in my opinion, used command lines. So we're gonna start with the command lines related to the images. The images are the environment that you're gonna create, and that's gonna include all the packages and softwares that are gonna be needed to run any application. So for that, we have the command docker build. My colleague, Dr. Didier, gonna show you an example of that and to give you more details. We have Docker images to list all the images, Docker RMI to remove the image, and finally, it's like dangerous one, Docker image prune to remove all your images. But Dr. Didier again, I'm gonna show you how to avoid this. Exactly. Next one is related to the Docker Hub. Docker Hub is just a service provided by Docker for sharing and saving your images. So in order to do this, you need to be logging into it using Docker login using your username. Then in order to publish or save your image, you use Docker push. If you wanna look for an image, you use Docker search. And finally, to download the image that you are needed, it's Docker pull. Just to give you how it looks like, you can, yeah. Yeah, exactly the same thing. Exactly. It can be private, yeah, of course, but it's running exactly the same thing as GitHub.
We have
Oh, this idea for that. But yeah, just it looks like this. So if you wanna, for example, Linux, type Linux, you get all the it's not showing. I have to stop the share. The stop the display settings. Okay.
Okay, now share.
I will share again. It works? Okay.
Yes.
So it looks like this. So if you wanna like Linux, you're gonna have all the distribution like Alpine, Ubuntu, Debian. If you look for like data science, Jupyter, an example, you're gonna have all the distribution related to this. Jupyter Notebook for SciPy, for Spark, which is a great thing if you wanna do some training on PySpark. There is already an image on this. Yeah. Really? Okay, I didn't know that. Okay. Okay, good to know. I didn't know that. So if you wanna like
compute node or and then my desktop, I connect to login node and then this login node go to the.
So
I are talking about iBooks, yeah.
Okay.
And this is, think of it as a server running something.
Yeah.
Like a REST how to connect from my laptop, I don't know, some content, then because I made my job is running on the compute node, right?
Yes.
So how is this setup of opening node? From my laptop running?
Interactive.
Yeah.
People actually.
Yeah. For singularity, yeah, exactly. Yeah. The idea. So this is the idea, just to show you how it looks like. Okay. I'll share the screen. The final one was, yeah, related to like this. Which one?
Yes, it's good.
Okay. No?
It's good.
So the last one is the containers, which are the instance that's gonna be run using the images that you have created. And we are gonna have to launch these containers Docker run using the name of the image, like we have seen, Ubuntu, for example. And you can add some parameters like the name to name the container, the P, which is very important to publish the ports of the container into your host. We have the V to mount a volume to share your local files with the container files to create like a bridge between the two. You have like Docker stop and start to start in a container stop it, run to remove, and finally the most used one in my case it's Docker PS to list all the containers, running containers, and Docker PS all running and stopped. So here, this is the cheat sheet, just that you can have an idea about the most used running command lines. So here, this is typical Docker platform workflow. So you look for an image, as I've said, you pull it, so you download this image, you start the container to run your application using this image, you stop the instance at the end, you remove it, and you remove the image. This is typical workflow. And I'm gonna show you a live demo, and we're gonna do it together. I hope so. Just that you can practice a little bit because you can have small exercise just after to replicate what we're gonna do. And yeah, the idea of the exercise of the demo is to run the most obvious example, hello world image. And then you're gonna try to do the same thing using the Ubuntu image to display hello world by executing a bash script from inside and outside the container. This is the demo. And we're gonna do it together. So if you have your terminal, I'm gonna show you. Yeah.
How effective if you run something in container or you run it on
Not just to show you how to manipulate the different commands. And for example, if you wanna do some stuff into the container, add in some packages, because when you install, for example, you are using Ubuntu, there is some performance.
There is more tuning required. Or memory.
Yeah, I can do this.
Platform that will be KSL thing, so it will be near hardware experience, there is virtualization per se, but because you are going away from the operating system that is native to the system, there will be some performance there, and there are ways to tune it, which is a little bit more involved, but we can.
Your workload is on GPU. We don't get that.
So you can actually access the GPU as if it was a bare metal and get the things done. So the resources will always be. You can size them.
I have a question about server. And we can upload it as repository. Can we work in Docker like in Git instead of GitHub? I mean, we work locally. So our image, we save our image in file or publish in repository. Is it possible?
I think so.
Yes.
Yeah, thank you. Yeah.
Place where Docker will run in the backend, will build the thing that you just pushed, the Docker file going on, and will do the pipeline of building and testing and will deploy, right? So that part needs to have some place to work, right? Sometimes you can find free resources, which actually are CI/CD services, which give you some server. But if you are doing something serious, you will have to set it.
It means if I, for example, I have bare metal, I have API and so on and so forth, can I set up bare metal? Yes, it's possible.
But you have. I feel it.
Yeah, pictures.
You can.
It this a little bit more.
Be generous.
Yeah, but
That is no.
see in my. Okay for you. Yeah. Okay, so we're gonna try to do the example here, of course, to download the first image using Docker pool. Hello world. Yeah, of course. Everyone should open his terminal. Is by default going to the Docker Hub. Yeah.
Do you want to?
Yeah, if you can, yeah, it's already. No, you can work
In
in your local machine.
local machine.
Yeah, exactly. It's if you have already installed the Docker desktop, you can open your terminal. It will be already.
Can you show where in the Docker desktop is the terminal?
Where it is Docker desktop.
I mean, we don't
Like-
have a terminal there, right?
This is the first question. On Windows machine, they have Docker desktop. Do they have a terminal in the Docker desktop?
Yeah, the command line, the command prompt or PowerShell. You can use PowerShell.
Can you show your Docker desktop?
Yeah. the Docker desktop looks like this.
Mhm.
And it's gonna already be into your PowerShell if you are using Windows for Windows. And the Linux, I think it's already in the terminal. And you have,
Mac is exactly the same.
yeah,
Linux, I guess, is the same. So we have here the different options, right? Container, images, volumes.
yeah. But for Windows users, you can use PowerShell. If Docker is already well installed, you're gonna find your Docker already running. It's running, yeah, okay.
For Linux, does it look like the same, like this?
Yeah, it's same. Yeah, exactly. This.
Word image, hello.
Okay, perfect. You have? Okay. Perfect. You can do it, but we're gonna see how to do this, to delete the image. Yeah, but it can. Yeah, it's gonna be like it's like overlay, so it's not problem. RMI, exactly. But before you use RMI, you have to stop any container which are being used this image. This is thing that you have to think about it. So yeah.
Okay.
So now if you wanna run a container, yeah.
So one thing to understand is, you install Docker, it actually installed all the components. If you remember, the OCI components I spoke about, one is the runtime, the other one is the images, the third one is the registry. There's a local registry on your machine now.
Yeah,
okay?
that's it.
So these registries will be syncing from Docker Hub to this. So the image came from that registry to this registry. The image is there in the catalog now for you to. Okay?
So now, if we run a container using this hello image, it's gonna give us hello world. It's gonna show display hello from Docker. This image shows that your installation appears to be working correctly. So you already. So with this example, yeah, it's okay for you. We're gonna try to do it, but this time using a Ubuntu image. So for that, we're gonna do the same thing. We're gonna look for the image. So to download this image from Docker Hub using Docker pool Ubuntu.
Let's
Yeah.
This will be the file.
Yeah.
Yes.
But install this, and then when the image is containerized, run that. Right, there is a command. It's kind of a cat. Okay, so that's what it is exactly doing. Docker run hello world image. It takes that image, unrolls it, creates a container out of it, and then runs.
Yeah, I'm gonna use the image that I've shown you on Docker Hub. It's gonna download the already prepared image and stocked into Docker Hub and
That's just like a hello world, like in Docker is running like.
okay. So I'm gonna download the image. I've already done it, so it's not gonna take a lot of time. And now I'm gonna run a container using this image. So if I do Docker run using the image Ubuntu, you're gonna see that nothing happens. But this is not the case. If we check Docker PS, for example, which lists all the running container, we're gonna see that there's no in non-container is running. But if we check Docker PS all, we can see, I don't know if it appears here. I don't know.
Yeah.
We can see that 19 seconds ago, a container was running, but exited. And this is normal because I didn't give him a job or to run any application or anything. So it started and stopped. But now I'm gonna remove this one first using Docker RAM. You can follow with me. You can use either the ID or the name of the container. Yeah, go ahead.
So for those who are interested, let me interrupt Halimi here.
Yeah.
So essentially, Halimi did a brilliant job, and he showed you that whenever he's running something, think of it as Linux, right? It is running it as a process, right? The PS command gives it away. It's a process listing, right? You can even kill the process. He's doing exactly that right now. You can run the process. The difference between Linux and here is it is keeping an archive of the process with the state, right? So even if the process passed or failed was running before, is archived with the state, right? And has an annotation as well. That's the name.
The name, yeah, default name, exactly.
That's the one.
Yeah.
Exit. How did it exit? Exit 0 is a good thing. Exit 137 is a bad
problem.
Something went.
Yeah. So now what you're gonna do is the same thing. We're gonna try to run new one, but this time I'm gonna add some parameters like IT to be into the terminal of the Ubuntu. And I'm gonna add also a name to my container, which I'm gonna name it like Ubuntu hello to display the hello world example. And I'm gonna use the Ubuntu image. Now I'm into the root of the Ubuntu. So here I'm into fresh Ubuntu. If I put ls, I'm gonna have all the files of the Ubuntu. If I can do like echo hello. But if I wanna create a bash script, for example, and here I'm gonna use, for example, nano, I'm gonna see that it's not found. And this is normal because it's fresh Ubuntu. So I have to install anything that exactly. So for this, we're gonna do like apt update, small one, big one. And we're gonna install the nano editor. So we're gonna do the same thing, apt install nano to create a bash script. This is the idea. So now, if I'm using nano to create a bash script called hello.sh, it's gonna work, and I can put like echo hello world. For nano, in order to save, you're gonna have to do in Windows. I don't know how to do it in Mac. Control O and Control X to quit.
It's the same. It's the same. It's
The same control? Okay. Okay, so it's gonna have. So now, if I list, I'm gonna have find my bash script, and I can do bash and run the script, which is in my case hello.sh, and it works. So now I run some scripts from inside the content. The idea is to do it now outside. But go ahead, yeah. Good. Good. Yeah. etc.
E.
Yeah.
With this will tell you which
Okay.
distribution.
Yeah.
We are not accessible.
It's Ubuntu, exactly. Yeah. It's Ubuntu on Windows because I'm using a Windows subsystem Linux. So this is amazing. So now I'm gonna quit my container. And the first thing to do, if you want to do it like from outside to run a script, first idea that you will have, which in my case I will do, is to do Docker run Ubuntu and add bash hello.sh. What do you think about it? In my case, I will do this to run the bar outside. But if I run this, you're going to see that there is an error, no search file or directory. But this is normal because you have to what do you need to know is that each container is independent and self-sufficient. When you run a container, you launch a new instance each time. So it's independent. So in order to find my hello.sh script, I have to look for the last container named hello Ubuntu. For that, if you want to add something, you can do it. I'm going to check Docker PS all, and I'm going to look for the Ubuntu hello, which is already exited. But in order to run it again, we're going to do Docker start. To start it again, using either the ID or the name of the container. I will use the name of the container, Ubuntu hello. So now, if I check Docker PS, it's running. And I can execute my bash script from outside this container using, there's a little like small exception, not Docker run, but Docker execute, using the name of the container and then bash hello.sh. And it works from outside. Yeah.
Just trying to recap.
Yeah.
This is brilliant. It's all happening. There is a lot for some. So I'll
Yeah.
recap a little bit. So one thing that Halimi has brilliantly introduced to you is a word called ephemeral. Okay. These containers are ephemeral. They will not exist forever.
Yeah.
In the state they were in. Okay. So he edited something, right, inside the container. Outside did not know. That's the isolation part. And he introduced the isolation brilliantly because the outside world did not know. So if you actually ask for it inside the container, when you exit it, it doesn't exist. One other thing that happened is Docker run rolled out the container from scratch, right? Whereas Docker start and Docker exit is doing a workflow where you have an entity that is existing and then you are trying to use that entity. So that's the major difference between Docker run and Docker exit. So the first thing that we need to capture is containers are ephemeral. If you want persistence in something, you will need to do some extra work. And Halim is going to talk about that extra work, and Didier is going to follow on that during the talk fight.
Yeah, so now that you have seen this, our work is done. Our application is working. It displays hello world. You wanna remove the image. Your work is done and you wanna remove the image. First thing that you have to notice and to take care is when you do Docker RMI to remove the Ubuntu image, your work is done and you finish. It's not gonna work. You need first to stop any container are using this image. So we're gonna check all the containers are using these images. You're gonna see that you have two. So to do this, the first thing that you wanna do is to do Docker remove. But it turns out that if you do Docker run to remove this one, for example, it's not gonna work also, because it's already running. So the steps that you need to do is to stop any container is running, remove it, and then remove the image. So for this case, we need to do Docker stop this container, not such container. Okay, Docker stop our hello. It's gonna stop. Take some time. Okay, it stopped. So you can check always using Docker PS. Now container is running. Then you can remove it. And it's removed. And then you can remove the image. I don't know if I removed all the containers using Docker. There is another one. This one. Okay, and now I can remove my image called Ubuntu. Yeah, you can add one again, like listed exactly
By name or by hash?
by name or by the ID. This ID, and to check all the images that you have, you do Docker image. In my case, I have already done some, yeah, exactly, some images. And yeah, now it's the part of small exercise for you, which is gonna be the same thing, but yeah.
So I tried again to run Docker and it showed me that firewall hello is already used by container. So
So if you change the name of it,
You have to do Docker execute, not Docker run. Exactly.
so the container already exists in the background, it is active. If it is active, you cannot unroll a new name. If you want to connect, with Docker, exec exit,
Exactly.
the name of the.
But
You have to put-
I put all the commands here in the next slide, so you can just check these commands and you do the same thing here. You have Docker start, Docker execute,
Docker start.
Docker start, Docker execute, and Docker. So you put all the commands in the next slide. Yeah.
Okay.
Okay.
If I work on a dashboard, just a picture, come back. It's good that I want to take that picture inside the image or outside the image.
As you wish.
Suppose I'm still there.
In my case, I work always using local files, but I'm gonna show you an example of how to create a bridge between your local files and the container. This is the last example. I'm gonna show you how to do it. I'm working always on it like this. I don't put a lot of things into the containers. Yeah. Yeah. You can. You try.
This is the trick.
Trick, exactly. Yeah.
You have everything outside the container.
Yeah.
You talk to the container and tell.
To launch any process
Yeah.
using your local files.
It can stay outside and can execute inside it.
Exactly. It's going to synchronize.
I say that you have a Fortran for Linux. or something.
Exactly,
You're
yeah.
working in a Windows machine. You can connect the outside file to execute inside the container. Get you back the result.
Exactly. Yeah. You can. Yeah.
This is the way of the Docker captain.
Yeah.
This is the actual term. Like if you are an expert in Docker, you are called a Docker captain.
Docker captain. Yeah.
So yeah.
I'm not. I'm data scientist.
Have that audio file.
We have
a container, then
Yeah.
That this is functional for some reason. I mean, the modules inside of HPC settings are useful because you have homogeneous thing for all the users. But if a user has to be more dynamic, then you need a container. And it will be also more personalized for what you need, right? Like if you know how to run the container.
I just find. I think sometimes good installation like that.
Yes.
That's something quite. Okay, my five.
Yeah.
Yeah. For example, in your case, for PySpark, if you want to do, for example, like training for others to how they use PySpark, you can use directly the image of PySpark. Jupyter One or I don't know.
Yeah,
There's a lot of images they use in PySpark.
There is some kind of errors that are very dumb. It's
Yeah.
like you install the same thing, exactly the same recipe of your Python or your conda environment in your laptop, You try to install the same on IBEX in one of them doesn't run for some reason.
So container here is very.
Is the answer.
Yeah, so exactly. Yeah, but this is just a small exercise for you. I want you to do the same thing, but this one displayed hello world, but this time not using a bash script, but using a Python script and using the image mini conda.
Yeah.
Exactly the same thing. So you have to download the image, run a container and name it like my first Python script, for example, create it using nano, as we said, okay. And then execute it from inside and outside and remove it at the end. So you can try it and you can do it for like 5-10 minutes, give them,
Yeah. If you can, please go ahead with this one. Or did you already did it? Okay, so try it. And once you fail,
so this way
can
you're
ask
gonna manipulate, but you can you have already the commands here, so you can.
Yeah.
In the previous slide, you can use them and adapt them to do the exercise. Yeah, the solution line in the next slide, but this is not the idea. You have to practice a little bit, but yeah.
This time we are running
Python instead of bash script and using a Maniconda image.
We are capitalizing on someone else's good effort, which was captured in this repository called Continuum IO.
Yeah.
And the container, the image's name is mini Honda 3.
Exactly.
It will have Honda environment,
Yeah.
Honda package manager installed.
I tried to do it using container this time, not not using Anaconda. Yeah. Yeah, to run a container and to name it my first Python script and to get into it to create a Python script into it.
If you don't do minus name,
Yeah,
it will
create a default
frequently
name.
call it something.
Yeah.
You can copy paste that always, but I'm sure you are not going to like those names.
Yeah,
No,
there are different names. They're from
the
list.
automatic-
I don't know.
the automatic name is one hacker name.
Yeah,
and
exactly. The
one-
hacker names. Yeah.
Yeah, it's a combination.
Running itself, we need to use them.
Yes,
Yeah,
It's a good practice to have.
yes.
yeah, because if not, you end up with a weird name of a hacker.
Yeah.
thing.
If a person is existing with that same name, you cannot read.
You can introduce. Exactly. Yeah, my first is for example. Minus name.
So one thing to know is your image repository and image name which you are pulling needs to be right at the end of the line and before the command that you're running, right? So if you put arguments over there, it will not happen. But check.
Yeah.
If it was this, so what he wants you to do is, basically, I can do anything, so if you want to share, right? That should be a. Put that in the. No. Yes. Everything. And this. And he. Yeah. Yeah. So now we're going to. It's already. Okay, so now we check it out. Yes. Okay, no. Now we're going to check that. It's and again, because it
Righty, last 2 minutes and then we move on, right? To an exciting session on Docker files.
So,
I mean, that's not obvious, right?
yeah, exactly. Exactly. I don't have the time to go through it in life, but this is the solution. You do Docker pull, Docker run, and name it my third person yet. You do the same thing using Nano to create your hello Python script, and then Docker start when you exit. Docker execute, and finally remove the container and the images. This is the idea. Now I want to show you the two most useful command, which is parameters, volume and port. So the first one is volume. Volume is to create a bridge between your local files and the container files. For that, I'm gonna use the mini container that you have downloaded in order to get access to my local Python scripts. So I have these commands that I'm gonna show you how to write. Just to give you an idea, and you can try it, of course. Have a lot of time. So here I'm launching a new container, name it local scripts, and I create a bridge using the -v between my working directory and a folder that I named my code, which I'm gonna find into my container. So if now I'm into my container, if I put ls, I will find a file named a folder my code. If I go into it, in my code, I will find my local files, which can be seen here. I don't have the zoom. Yeah, but the idea is these files are the same here in my local files. And I can run my scripts, my local scripts, Python scripts, through a container using a specific image. I'm data scientist. I want to work, for example, for using Miniconda and executing a lot of things. I'm going to use this volume bridge, but it can runs any application. It's not specific to the resource. And the final one is the port, which is to publish a port between your containers and your local one. And for that, I choose a small example for Jupyter Notebook. It's an image. And if I'm gonna exit this. It creates a bridge between 10,000, the port 10,000 and 880. So if I launch this and I copy the link of the Jupyter Notebook, put it here. And change the port 88 by 10,000. Yeah. A Jupyter Hub lab with my folder, my code. I'm gonna have all the files, the local files, and I'm using a Jupyter already with the most used libraries, like for data science, because I've used an image for data science, Panda, NumPy, Seaborn, Matplotlib, already installed, and I can already do my works. And thanks a lot.
So before you go,
Yeah,
let's
but-
recap what you
yeah,
just said.
exactly.
It's a brilliant stuff. Last two things that Halimi said, and repeating so that it gets ingrained in the head. By default, what happens is when a container starts, it's an ephemeral thing. We have decided that already, but it brings its own file system, right? There's nothing extra in there, right? Nothing from the host per se, from the file system point of view. But the intent of the container is always to be lightweight, right? So you cannot put too many files, too heavy files. So what do? My files, my source is my important thing. That's what I want to work on. These notebooks and all those things, the checkpoints, the assets that you're going to create within that environment. Volumes are to be bound and mounted. Bound and mounted. So the mount point was /my_code, and the source was the directory on the host that we wanted to expose to. Now, this is the way to introduce persistence of the data when you are doing the container build. Okay, so that's one thing. The other thing that doesn't happen is, and it is a brilliant thing from isolation point of view, remember that VMs used to, well, VMs create their own port list, right? They have all the port. 8888 exists inside and outside on the host separately. Same is the case with the container, right? There's a different 8888 inside and outside. You need to link them together, and then you can link them such that the inside port can actually map to the host port, which is different name, which is different number. That's exactly what Halimi did. And this is absolutely important when you are actually working on a shared machine. The host can have only one 8888, right? What if there are all of you working on the same system? That could be 10,000, 10,001, 10,002, and so on and so on. So this goes for shared machine from an applications perspective as well. If you have a distributed system and all of them require a port, you can actually expose different ports.
Exactly.
So thanks a lot,
Exactly.
Halimi. It was absolutely wonderful. Let's move on to the.
And I give the floor to my colleague.
Okay.
Thanks a lot.
So for this next part, can you please clone the GitHub repository that is up in the slide?
I want to add a few just the recording can go on this. It's being recorded, right?
Yes, it's being recorded.
And then you share yours. That's.
Nice.
Just move.
Yeah,
Okay,
don't
stop
worry.
sharing.
I just stop sharing. Now this is mine. Okay.
Stop sharing.
Yeah.
Okay. Thanks. Go ahead.
But it might be a scope. It might be a scope. Isn't, let's go to this one.